So today what we will wind up with this let and lambda, and then we will see with respect to the application of let and lambda how we will be using it. So previous class we just discussed about the syntax of let as well as lambda. And we have done a few examples during tutorial session. We just completed with how this let works as well as lambda works. We have seen. So as a conclusion part. So first two examples we have already discussed. So let we had single variable which has been initialized to value 3, that to variable x. So as a body it will be executed. Wherever x is there, it will be replaced with value 3 and this expression will be solved. So first 3 into 10, 30, 30 plus 3, 33 will be the value which will be returned here. Coming to the example 2, we are saying that if there is a global variable x which has been defined to be as 5. So that means define x 5 has been done outside this let. After that you are having this expression that is plus let x3. It is visible. Yeah. Plus let x3, that means 3 has been initialized to the value variable x. That means now x is acting like a local variable here. So this becomes our global variable, that is this x equals to 5 becomes our global variable. This x equals to 3 will become our local variable. And now as a body of this let, so inside the let part, that is where this brackets are getting closed, it is getting closed here. Inside this, wherever you are accessing x, x will be replaced with the value 3. So x, so wherever you are having this x inside this let, you will be having replacing the value to be as 3. So 3 into 10, 30, 30 plus 3, 33 will be the value which you will be getting as an output for this let part. Still the expression is not completed. Still we have plus x. So what happens? Plus, so 33 plus x. So what is this x value? A let is already closed here. So once the the scope is finished over here, can we access the x to be as 3? We cannot access. So what will be the x variable value which you will be getting? It will be accessing the global variable one. So the value for this x, it will be 5. So you will have the expression written to be as plus 33, which you got from the let part by replacing x to be as 3. After that, outside this x, which will be the global one, which is 5. So your output will be 38 for the example 2. Okay. So coming to the example 3, if we are similarly we are saying if we have an x equals to 2. So that means we are saying that we have a global variable named x which has been defined to be as 2. So that means define x2, which has been already done. Now if you see the let part, so let x equals, that is x3. So that means 3 has been assigned, x is a local variable which is getting the value to be as 3. Now if you see, we haven't closed with the assigning part. We have another variable y, and which is being assigned with plus x2. What happens here when you are trying to solve this expression? That is, to a variable, the value when you are trying to give, you will not be able to access this x. You will not get this x because this is a local one. When you are assigning, when you are having an expression during your for these variables, if you are having some expressions, this x will be nothing but it will be accessing the global variable one, not the local one. So be careful here. So this x, it will be the global variable one. So it will be in the global variable, what we have is 2. So you will be having 2 plus 2. So y will be assigned with the value 5. Y will be assigned with the value 4. It won't be 5, it will be 4. Why? Because during your inside your let, any new variables you have, and for those variables, if you are assigning any value, that means if it is directly constant, well and fine, that constant value will be assigned. What you have seen in this x3. If there is some expression, the expression to solve this expression, if you are making use of any variable, those variables should be the global variables. So it will access the global variables here. So this x will be the global variable which is 2. So 2 plus 2, so it will return it to be as 4. So y will be assigned, y which is a local variable, which will be assigned with the value 4. Now it will execute the body of the let. So it will be x which is 3. So this part you will be having multiplication of 3, which is the local variable x. So 3, y which is value 4. So 3 into 4. So you will get the value to be as 12. So this part also we have seen in the tutorial session, if you remember. So as a conclusion for this, if you see this expression, that is function x and y. So if you are giving the passing the input for x and y, this expression we have to solve. So what we have done is we have represented 1 plus xy to be as the variable a, 1 minus y which has been replaced with variable b. So now if you see 1 plus xy which is already a, this is again b. So I can rewrite this function to be as ax plus x a square plus yb plus ab, right? So usual way of defining I have done here. If you see here, define f. I just gave the name of the function to be as f. I have two arguments x, y. Inside this, I have another sub-procedure defined, f helper, where I am passing a and b values. So that means I am expecting this a and this b to be passed. As the body of this expression, what I will be having? X a square. So if you see multiplication of x a square, then next expression is yb. So multiplication of yb. After that we have ab. So next is ab. All the three things which is getting added. So all the three things we have summed it up. So plus first expression, second expression, third expression. We have closed this portion. After that, what is the next statement? What we have is, I'm once again I'm calling this f helper procedure by passing what should be my a value. That is my f helper I have closed here as the body for this f function. I'm calling this f helper with what values? What is my a? My a is 1 plus xy. So I have written my a to be as 1 plus, that is in the prefix format. So plus 1 multiplication of xy. Close the bracket. What about b? B is nothing but 1 minus y. So in the prefix format, my b will be 1 minus y. So this is the usual way of writing our procedure by using some names. If suppose, if you want it to be written with respect to let or lambda, that is also possible. So by using lambda, this is one possibility. So how I have written is define f xy. So same thing as the body of this part. So this part I have redefined with respect to lambda. So whenever we are using lambda, what is the main thing which we have to remember is there, if you have to call that procedure, there itself we have to call it. Or yeah, you will see it in the next coming session when you have to returning how it will, when you are returning a procedure itself, then how the procedure call should happen. So here what we have done is f xy. So here I have defined, instead of giving a name like f helper, I have defined it with respect to lambda itself. So lambda, the definition of the procedure, this is the bracket which I have used starting. So this I am closing it here. If you see, it will be closed here. So lambda, a and b are my arguments. As the body of my let, I have plus first expression. So closing of the first expression, closing of the second expression, closing of the third expression. So third expression closed here. This is for plus. So lambda is getting closed here. So I've closed the lambda part. Now I have to pass the a and b values here itself. So for that purpose, what I have done, we have to open a bracket. So one bracket is being opened where I have my a passed. This is my a. This is my b. And then I have closed this lambda procedure call part. Sorry, procedure call has been closed here and define f has been closed here. So that means from outside when you are calling, you can call with respect to f of say 2, 3. So based on this x and y, what happens? This F23 when you call, you will be returning this lambda procedure. What about A and B values? A and B values will be calculated with respect to this x and y. A and B will be assigned and then this body will be executed. This is how the execution is going to happen. Okay. Same thing, you can do it by using let also. So if you are using let, the same procedure, how you can rewrite is, first part, I left it as such. Define f, x, y because each time based on x and y values, it keeps changing. So I have given a name for the outer function. So f, x, y. Now if I am using let, what happens? I will be using the local the variables and the values will be assigned there itself. So let, if you see the syntax part, let first this bracket will be for assignment of all the arguments. So sorry, not this one. So assignment of B. So A is this one, closing of A parameter. B we have closed here and this bracket we have closed here. So once we finish all the variables being assigned, we will be closing this assignment section. Once the assignment section is closed, then the body of the let will be starting. So what happens is let A has been defined with 1 plus xy. So in the prefix notation, we have written plus 1 multiplication of xy. Closing of the brackets and the A variable, this A variable's local variable definition has been closed here. Next, we have another variable b. So opened another bracket. B will be assigned with 1 minus y. So in the prefix notation, we have written minus 1y. We have done with all the variable declarations, definitions. So we have closed the definition section of the variable let part. Once the definition section of the let is closed, the body of the let will be starting. So what is our body of the let? Plus x a square. So how do we write it? Plus x a square. So multiplication of x with a square of a, closing part. Second variable is multiplication of yb. So multiplication of yb. Next is ab. So ab, how we can write as multiplication of ab. All the things, all the three expressions should be added. So we have closed. After this is for plus operator. This is for let part. Then I have closed for the definition of function. So like this, we will get 4 parentheses as the closure part. So here also, when you are calling this f of 2, 3, what happens? It will have the let. So let, what it does, it assigns the it defines the a variable, it defines the b variable, then this body will be executed. So you can define a procedure by giving some name like sub procedure like f helper, or you can define a procedure by using lambda, or you can define a procedure by using let also. So based on the situation, based on the application where you are using it, you can use it accordingly. Okay, so one procedure can be written in any of these 3 ways. Okay, keeping that as a note, I'll stop with this. Uma ma'am will be continuing with the application, so which is the half interval part. This slide I have already uploaded. I'll stop sharing. Uma ma'am, you can continue.
Yeah, thank you, Sriba.
Thank you.
Hello, students. Very good morning.
Good morning, ma'am.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Is my screen visible to you?
Yes, ma'am. Yes, ma'am.
Yeah, so I hope you understood lambda and let. Which one do you like? you feel that let is easy to understand and lambda is easy to understand, or both are equally understandable? Any answer? Any answer? Students?
Ma'am, both are equally understandable.
Okay, very nice answer. Okay, so with the help of let, Sriba has explained the local scope and the global scope as well, right? So within the let function, any variable is defined that has a local scope, and outside the let, whatever is available, that will be global scope. Okay, so now let us go for the applications of let. We are going to use the let. And we are going to take an example of finding the roots of an equation. How to find the root of an equation, right? So there are several methods available, but particularly we will be going for a bisection method. So in your engineering lower semesters, I hope you must learn about this bisection method. What is the bisection method? Students, anyone? This concept, did you know already? Using the bisection method, we can find the root of the equation. I can say it is a polynomial of any degree. Okay, anyway, so let us look at the procedure and then we will start write the program. So let us take an example function x cubed minus x minus 2. So there is a function available, there is a polynomial given for which we would like to find a root. So what is under root actually? So given f of x and some value if you are substituting for x, and it is going to give you a value 0. So for which value of x, f of x is 0, right? Then that x will be the root. I hope you understand. If you substitute some value for x, consider it as 1 cube minus 1 minus 2. So 1 minus 1, 0 minus 2. So 1 is not the root, right? What we are after all going to find, f of x should be 0. For some x, that x is considered to be the root of the given polynomial, right? And this bisection method is very helpful for finding a roots for the continuous function. So given the continuous function, we are going to find out the root. Okay. And for solving this problem, another two inputs as well will be given. One is A and B. Okay. So what I'm going to do is, given A and B, this interval, what is the root? Where the root lies. Okay. So given the interval 1, 2, where the root lies, whether it is 1.5 or 1.7 or 1.9, what it is, where it is. Okay, as I said, it is a continuous function. That means you will have a sine wave or something, right? Some waves, kind of wave, and provided in the x-axis, it will cut somewhere. So that cutting point is called as a root. Okay, that also we know, we have studied in lower semesters. So with the help of a bisection method, find out the root. Okay, for which I want 3 values. One is the function, another one is lower limit and upper limit, right? So how the procedure going on, how to find out. So what I will do is, I will find out f of A, I will find out f of B. Okay. If you apply this, instead of x, if you apply 1, you will get minus 2. If you apply minus 2 to x, you will get plus 4. So now, because the function is continuous, there must be a root within the interval 1 and 2. That is our assumption. There must be. Okay. So within this interval, where the root lies, for which what we are going to do is, going for repeatedly do some operation. Okay. What is the operation? Right. So what we are doing is, we will find out a midpoint. So given the lower value and the upper value, so 1 and 2, and what is the midpoint? So you will have 1.5. So after that, what you will do? So for your understanding, I have given you a table. So if you apply 1 and 2 to the function, 1 and 2, what is the middle value? It is 1.5. Take a middle value and apply to the function. That is f of 1.5. F of 1.5, you will get some value. You may get a positive value or you may get a negative value. If it is a positive value, what you have to do? If it is a negative value, what you have to do? So now in this case, for the application of 1.5 to the function, you are getting a negative value. So if it is a negative value, the f function is a negative value, you have to search in the right side of, okay, so given a line, okay, there is a lower limit, there is a upper limit. Consider this is a lower limit, this is upper limit, and you have a midpoint lying over here. Now, if you get a negative value, search in this higher part. If it is a positive, search in the lower part. Okay, that is the concept. So now, because we are getting a negative value, there is assumption that the root will lie between 1.5 to 2. If you look at this, there is no change in the higher value, but there is a change in the lower value. So the midpoint will be acting as a lower value for the next iteration, right? So for 1.5 and 2, what is the mid value? After finding a mid value, apply to the function, you will get a value. So what is that? It is a positive value. If it is positive value, you have to change the upper limit and keep the lower limit as it is. Okay, so here in this case, because it is a positive value and we have started 1.5 and the mid value become a higher value. So this procedure is going to be continued, okay, by seeing what is the value of function. It may be positive or negative, and you will be bisecting the interval, going to the left side, going to the right side, and you are doing many iterations. Now, if you are writing a program, at any point you have to terminate, otherwise it will give you an infinite answer. So how to terminate? So look at this. This lower limits, what happens is here 1.5 to 0, 1.5 to 1, and you are still continuing. What happens is, see the interval. The interval between A and B, if you look at, always it is going to be closer. Okay, the difference between the upper value and the lower value, if you look at, it is very, very small value. Okay, so here in this case, we say that the answer is going to be converging. Okay, so what is the root actually? After all, what is the midpoint? What you are finding, that will be the root value. Okay, so if you find the root value in the previous iterations and comparing to the next iteration value, it is all converging. Right, so and if you look at the interval is very, very closer. It is very, very minimal. Right, so at this stage you will be stopping the iteration. Okay, so I hope you understood. Any doubt in this?
No, no.
Okay.
We had this in our course, ma'am, like in single variable optimization algorithms. We even coded for this part.
Okay, very good, very nice, very nice. So now this bisection method is also called as a half interval method. By seeing this iteration, we can very well remember that it is a binary search something, right? So this bisection method can also be called as a half interval method, or we can also say that binary search method, right? Okay, so now let us go for writing the procedure. And we know how to write a procedure inside another procedure. So there are a kind of, what is that? We can have a modularity. We can build a modularity in the list. Okay, a procedure can have another procedure, and we can call inside. All those things we have already studied. Okay, let's look at what is our problem. The problem is finding the roots of an equation by the half interval method. So the assumption is, because it is a continuous value, continuous function, x must be 0. Okay, so I'm just taken, I have taken sentences from your book so that it will be easy later when you scan through the book. So now the idea is, there is f of a, that is f of b. Okay, and then in the middle you will find the f of something will have a value 0. That is the assumption. So for at least one value of something x, okay, you are going to reach 0. So that is the assumption. And to locate 0, we have to perform many tasks. Okay, what we are doing is, so I'm just writing in the normal way, without, that is, I'm not remembering the Lisp language or whatever. Okay, so now what I will do is I will find out the average of a and b and then compute f of x. And if f of x is greater than 0, then f must be between a and x. If f of x is less than 0, that means a negative value, and the f must have a 0 value between x and b. And then if f of x is 0, then return x. Okay, so you have to repeat the process till the interval is small enough. You have to decide. So how much you want, what is the small enough, that you have to decide. So this is the terminating point. Okay, so the process is stopped, right? And another thing is, okay, let's look at the example program for doing this operation. Okay, let's look at it. I'm going to define a function. The function name is search, right? And for this search, okay, what are all the inputs I have to give? First of all, the function. What is the continuous function? The polynomial, I have to give an input and 2 arguments, negative point, positive point, that is a and b, the lower limit and upper limit. Okay, so some negative point and positive point. So I want to find a root between -1 to 0. Okay, or with some interval. Okay, so now, so there are 3 arguments. One is the function for which you want to find out the root. Another is another 2 are lower limits and upper limit. Okay, so now we are just imitating our algorithm. First of all, the first step is you have to find out the midpoint. So midpoint is nothing but average of negative point and positive point. It is a and b. Okay, this is our assignment statement, so that we are going for the let. Okay, whether let is closed, let will have 2 parts. One is assigning value and then the body. Yes or no? So now, and inside, if you look at close NF is another function, and for which there are 2 arguments a and b. So I told that given the interval, that the lower limit and upper limit, and this lower and upper limit are very close enough, then you have to terminate, right? That is what we have written here. If a and b, negative point and positive point, are close enough, what if statement will do? If it is true, return this, else it will go here. All right, so always you will have a confusion by seeing this code fragment. You will just you will not, it's something complex we cannot be able to identify, or we cannot be able to write on our own, but it is very simple. So the preliminary part, the elementary part, the syntaxes you should know. If statement, how to write if, then the condition. Okay, so here what we are doing is the close enough we are calling. The close enough must be returning true or false, right? For the close enough, we have 2 arguments, and it is going to return you a value, midpoint. So what happens is this midpoint, where it goes, where you are returning, Okay, let's look at. So now, if it is not enough, if it is not close enough, go to the else part. In the else part, you have the let. Okay, another let. What you're doing is f of mid you will find out, where f is a function, right? F of mid and what? You are assigning something to the test value. Okay, so you will apply this midpoint to the f function and then get the test value. Okay, with the test value, what you're doing, I will find out whether it is positive or negative or what else. Okay, so that there are three decisions I have to make so that I'm going for a can't. Right, I'm not using if means if part and else part. There are two conditions I can make, but here I want three. So as per the algorithm, so if you look at the previous case I show you later, so if it is a positive, the test value is positive. Okay, and do this, what you are doing, you are calling back the search with f with negative point and the midpoint. So now this upper limit will be the midpoint. If it is a positive, you have to search in the lower half. Okay, if it is negative, then you have to search in the upper part, where in the upper part the lower limit is midpoint. Okay, else what you're doing is you are returning the midpoint. Okay, so sit in your free time and just trace it out. Okay, because here the brackets are very, very important, and we are not at all using the assignment statement. See, the statements are not what is that, primitive. So now let means you will have something and then body is available. If means some condition and then something and then else is there. You have to know the syntax, then only this language will be easier for you. Okay, so though in the top level, if you are looking at by knowing the algorithm and then seeing the code, you can able to understand, but you cannot able to write after closing your slide or book. Okay, please you just practice. Okay, take some other problem and just practice it. Okay, so this is what finding the roots of an equation. Okay, so what is close enough? In the previous case, we had a close enough, right? And this is, we are using a modularity and how to. So the close enough will be written like this. Close enough for which x and y are given as input, and what we are doing. So x minus y, and then find the absolute value, and that absolute value is less than 0.01. Okay, if it is less than 0.1, what it will do? What it will return? First of all, tell me, what is the return value? Tell me. You have a less than operator, and then two values. One value is absolute of x minus y. Another value is 0.01. What it will return? If you have it will return. It will return x or y. It will return x or y. See, consider less than, within a bracket I have less than 2, 3. What it will return? Less than 2, 3. What it will return? Once again, please.
True or false?
Yes, it will return you true or false. It will return you true or false. Less than one operand, another operand. All the relational operators will return you true or false. So that this close enough is used here. If close enough of negative point, positive point, consider this is x and y. It is substituted there. It is going to return you true or false. So if it is true, the whole statement, no, close enough negative point, positive point, it is going to return you true or false. If it is true, then midpoint is returned. Okay. So at any point, the primitive thing, elements of Lisp, primitive elements of Lisp, you have to understand. Then only you can write a program on your own. Okay, right. So here you had a confusion, right? Always we expect a true or false. Okay, but you are calling a procedure, so the procedure has to return you true or false. Okay. Right. Okay. Another method for half interval method, but we are just going to optimize this. Okay, the previous algorithm is going to be optimized. So what is optimization we require? Whether the previous algorithm will work properly for given two numbers A and B, given the lower number and upper limit number, whether it will work properly or not. It will not work sometimes. So consider, I tell you the case when it will not work properly. Okay. Consider I'm giving minus 2 plus 2. Okay, minus 2 plus 2. And find out the average. Minus 2 plus 2 divided by 2, 0. Right? And moreover, this program is not testing whether this negative point, positive point is, whether really it is negative or really it is positive, it is not. Okay, it is not doing, right? But it is testing this one. So now we are going for, actually this algorithm will fail for the interval. If we are giving randomly, it will fail surely. Okay, so that we are going for the optimized algorithm. What we are doing first of all, okay, we are defining a half interval method. This is a function. I'm going to define it for which 3 arguments: function, lower limit, upper limit. So now f of a is a value, f of b is b value, and you check whether it is positive or not. Okay, and positive or negative, whatever. So depends on that, I will pass the parameters for this next iteration. I will call the search function for the next iteration. See, look at here. F of a I am finding, put in a value. F of b I am finding, put in another value, variable. Now, if you look at a value is negative and b value is positive, okay, both are true, then call the search with f a comma b. Okay, otherwise a is positive and b is negative. Okay, both are true, then call the search function with b comma a. After all, we are going to use the search function. Okay, but we have done some kind of testing. Okay, so nowhere it should go wrong. It should work. I have to write a generalized procedure. It has to work for all the cases. Okay, so here I am calling the previous search, what I have written. Okay, so this is the one we are calling it over here. Right, now we have defined the function, but how to call this? How to call the half interval method? The half interval method is going to take 3 arguments. One is a function and then lower limit, upper limit. What is the function? Okay, you may think that I have to give a polynomial. Yes, you can give. And you can also have a sine function, cos function, that also possible. We can find a root for that as well. Okay, so in the half interval method, I'm just passing sine and then 2.0, 4.0. So what happens here, f is taking sine, okay, and 2.0 and another one, and you're testing it, and then you're calling the search. Depends on the positive value, negative value, etc. And f is here sine. So going to the search, very sorry, I have clicked so many things. So the search, and here's it is sine. Okay, so what it will compute, you will come here and you will find what f of midpoint, what it is sine of midpoint. So all the f will be replaced with a sine function. Okay, so all the things will be that is f of x is nothing but what, sine of x here. Okay, sine of x, that x is nothing but midpoint, always a computation of midpoint in each and every iteration. Okay, so I have called with a sine function. This is the way I can call. Okay, so we are talking about how to pass the function as one of the argument. Here we are passing the function. Okay, let us take another equation, polynomial, and between 1 and 2 we have to find. So how to call? This is one of the way. Function name is half interval method, and this function I'm constructing as a lambda function. I don't have any name. Okay, so in the execution time, I'm just simply passing this function using the lambda function with a nameless function. So how to define this? Lambda of x is nothing but x cube minus 2x minus 3. Right? So this is the lambda function. and how to pass the value. So this argument, if you look at this as a function, close it, and then second argument, third argument, and then close the call. Okay, this is one of the way you can pass a function. The lambda is useful for calling a function. Yeah. Next, look at. I have a function defined fun. Fun is defined as x cube minus 2x3. In this case, I didn't define at all, and I am just using the lambda function. Now, there is an explicit defined function, defined statement, defined function of x. What? This is the one. The same thing I have written here. So now this is a user-defined function, right? And how to call it? What is the name of the function? Fun. You just pass it over here. Okay, so from this example function calls, you can just understand, you can learn like I can pass a built-in function, sine, cos, tan. I can even pass a nameless function which will imitate my polynomial. Or I am defining a function that a user-defined function, and that function, user-defined function name can be passed as an argument. Any doubt in this? Any doubts? Okay, let's look at what is the order of growth for this particular example program. It is nothing but log of L by T. Why log? Why log? It is using a bisection method, right? In a binary search, what is the complexity? Log of, right? So log of what? L by T. What is L? L is nothing but length of the original interval. What you're going to take, 2 to 4 or 5 to 6 or 1 to 5, that interval, length of the interval divided by T. T is nothing but a error tolerance. What is your error tolerance? I can say 0.0001. Okay, it depends. 0.1 I can also give. So what is your error tolerance and what is the length of the interval? Okay, it is based on that. Okay, so always the order of growth is nothing but number of times the iteration going on, right? So this is nothing but log of L by T. Why? Because we are going for the half interval method at any time. Okay, if you look at the data, the interval, that is we are closely reaching the answer by off, that is by deciding the midpoint of given interval. Okay, that's fine. Right, thank you so much. If you have any questions, you can ask me. I hope you understood this program. Okay, and look at my this one. Look at this algorithm and sit and do this out. Where the bracket is, where it is closing. All those things matters. Okay. Any doubts? Students, are you there?
Ma'am, I have. Ma'am, like we are using let and lambda, so both are higher order abstraction. So is it possible to differentiate between let and lambda? Like I have a problem and which one I should use out in let and lambda? I can differentiate between these two, let and lambda, based on the complexity, like how I use it.
Yeah.
Can I test?
Yeah. So let means you have many assignment statements, right? You will assign some value to the variable and then the body section will work on. And for the body section, you need some local data, right? Outside the let, you will have a global scope. Okay. Now, if you take the lambda function, lambda is actually, we have actually, as a programmer, I will be writing a function, define a function only when that function is useful in my program in many places. Okay, in order to avoid the redundancy, I will go for the lambda function. Yes or no? Sorry, I will go for defining a function, right? So now you want to define a set of statements which are used in only one place, for which you no need to give a name. Okay, nameless, that is nameless procedure you are creating and you are using it. You will not require at a later point. you will not require at a later point. This is a kind of optimization. Why? Because whenever you are defining a function, the entry is made in the symbol table. Okay, it is occupying some space, right? But in the case of a nameless function, right, there is no entry in the symbol table. If there is no entry in the symbol table, that means you cannot once again call the same function, right? So it is up to you. What are the statements you would like to write as a function? Usually for maintaining my program in a modular way, I will write a function. And then modularly, I will call the function whenever I want. Okay, so that is the main reason I will go for a function. And so another, why you have to go for the lambda function? That means I will not call it again later point in my program. So in that case, you can use the lambda function. So while writing a function, lambda function, that means something you are containing it. Okay, so somebody is seeing your program, they can able to understand better. Yeah, so normally the Lisp interpreter, what it does is all the functions are converted into a lambda form. Okay, so if you are writing the same thing as a lambda, so the interpreter will not once again interpret and convert the function into a lambda. So in this way, your computation time is reduced. Any other doubts? I hope you understood.
Yes, ma'am.
Thank you. Okay, thank you, students. So let us meet tomorrow. You have a quiz as well. So after the quiz, I will be continuing my lecture. Thank you so much.
Ma'am, in the quiz, what type of questions will come? Like fill in the blanks and
yes. Yeah. So given a code, you should be able to write a output, or given a task, you should be able to write a program, all those. You can ask Sriba, ma'am. Yeah, Sriba, are you there?
Yes, ma'am. Students, you will be having tomorrow morning itself, all of you join the class. So for first 15 minutes, you will be having the quiz. So quiz, you will have fill in the blanks kind of questions as well as output kind of questions. Like multiple choice as well as fill in the blanks. So these two type of questions you will be having it. And before coming for tomorrow's class, make sure that all of you are having the subject code 15 CSE 402 in your AUMS. Especially Durga Sai Prasad, if you can reply back. And Raghuvamsi, if you can get back, whether you have these two classes added, it will be good. Tomorrow morning, if you come back saying that class is not found or something, we can't help it out. So today, if you have, we can sort it out. Durga Sai Prasad and Raghuvamsi. Raghuvamsi re-registered student. Okay. After the exam, you will be having the class. Okay. So shall we wind up?
Yeah, if there are no questions, we can wind up, Sriba.